Yes. Okay, this one is Amazon RDS for SQL Server supports M6i, R6i, R5b instances in additional regions. So let's see. First, the R family is growing itself. You did some research on trying to differentiate the R instances. What are your thoughts on those?
Yeah, to be honest, it's starting to get pretty confusing. So you have the R5 family. You have the R5s, which are the old Intel processors running at 3.1 hertz. Then you have the R5As, which are the AMD family of processors, and then you have the R5B, which are the latest generation Intel instances, also running at these are latest generation Intel ones that are running at 3.1 gigahertz, but can peak to 3.5 gigahertz. So that's pretty interesting. But at the same time, you have the R6 family already there. So you have the R6As, which are the latest EPYC processors from AMD. And then you have the R6G, which is the graphics-based processors, right? And if you look at the price difference, the Intel ones, that is the R5 and the the R5B, are both about 20% more expensive than the AMD family. That's the R6A as well as the R5A. I'm already getting very confused as I talk about these. But the R6G, which is the latest processor, is about 40% cheaper than the R5B, which is the latest one that Intel just
So I think that our advice then is going to always be the same: is stick with Graviton unless you have a really reason not to.
Correct. I mean, it makes absolute sense to just stick with the Graviton processors for RDS. And though I'm not entirely sure if a SQL server specifically runs on the R6Gs.
I see. So even though there are R6Gs, but that might be R6G for MySQL or Postgres.
Correct.
Okay.
But there, the answer should basically be, I have to check whether the SQL servers will continue to run on or will run on the Graviton processors. I doubt they do, but at least the R6As should run. There should be no reason to run the R5Bs anymore because the R6As are already faster and cheaper by 20% over the R5Bs. So I don't know why people will want to use more R5Bs.
Now, if we look at the R6i itself, that's a lot of compute in a database instance. Who are using these why do you need so much compute? I thought for databases, it's mostly about memory and storage. Why do you need that much compute in a database?
So the I instances are mostly about IOPS. Okay, now base need tons of IOPS and memory. What happens with the database is you want to take all the stuff that's in your disk, load as much as you possibly can into memory, and then your CPU operations are relatively straightforward because they just look at memory address, looking at your indexes, in the data, and pulling it up. Right? So
joins and all that.
The CPU operation is relatively light when it comes to databases. It's mostly about your disk IOPS to load stuff into memory and how much memory you can give the database. Now, the funny thing is that, especially with SQL Server, there's a history where tons of products have leveraged historically a lot of stored procedures. So they've used these databases almost like compute. And I think that's where the big problem lies. They've stopped using the database like a database. They use it like an app server. With a lot of business logic kind of shoved into those databases. And I think that's the wrong approach. I don't think you should be doing that to databases. They were not originally designed to do that. There's tons of hacks that have gone in. You want to database operation as light as possible in the relational model and keep the logic outside. Today, you don't have any of the trade-offs to be made, whether it be network or CPU or IO. You can get all of them outside of the database. Back in the day, you had to move 10 gig out of the DB into your app server, you would think twice. You'd really question how you're going to get that because the latencies were crazy.
So in this case, you always think, okay, well, I've got all the CPU power. I'm not limited. I just need to go to the 32x large, which has 128 CPUs.
Correct.
But then you're not thinking, okay, you're not bumping into this constraint where you're thinking, is it really a good idea to put all of this business logic or data processing? I mean, I've seen machine learning models built as there's one place I did a consulting project and I saw a machine learning model that was built out of a generated set of about 1,400 stored procedures. They were wondering, why is the database getting so slow? And it was this incredible just mountain of stored procedures that created thousands of intermediate tables and all stuff. And it works in theory, but it was definitely not the right approach.
Yeah. Also, from software maintainability standpoint, it's just untenable in the long run. I mean, I've seen products with over 1,000 stored process, and you don't know how to deal with it. Migrating to new versions becomes hard. Migrating off of the expensive licensing into more common databases is incredibly hard because your business logic is all over there and you don't know how to deal with it. So yeah, it's a really tough space to be in. If you have tons of stored, try and get that out there so that you're more flexibility, and then you're using the database itself for its core operation. If you look at the instances over here, all of these instances have 12.5 Gbps at least in terms of network bandwidth. Some of them have over 30 Gbps. Right? I mean, if you look at the R6 ID to 24, they use 37. Yeah, all the way up to 37. The R6 metal goes up to 50.
So you'll be able to get your data out.
You can get your data. I mean, that's the network is no longer a constraint like it used to be, even just a decade or two ago. So yeah, stored procedure, I think, is one of those, sorry, it's one of those bad practices that has come in with the relational data source and has stuck around.
Well, and not just that, but they're not commented very well. They're not version. Yeah. It'd be great if they had CI/CD around them, but often they're just, you open the stored proc editor, write it down, and then someone else finds it and builds on it. And There's not even a lot of thought that goes into actual data dependencies or redundancy. It's just easy to find one view that already exists and build on it, and another one.
Correct.
And the same, you can have a lot of redundant computation, but SQL doesn't really help you with that.
True. So you want to get rid of as many of the stored procs as possible and move them into business logic that you can manage, maintain, just make your life easier. Keeping them in stored procs isn't tenable in the long run.
Yeah, absolutely. So going back to this article itself, RDS for SQL Server, what do we think? I mean, this is obviously simplicity in the sense that if you didn't have it before the regions and they do, life is better.
Yeah, I think so. M6i, R6i completely makes sense. Definitely simplifies. The one point that I would ding for is the R5B, because I don't understand why you would want to launch the R5B. The R6A should be a better option for SQL Server.
Is it? I guess so. They're saying R5B compared to R5, but then why would you just go to R6?
R6A is already there. R6A was launched some time ago, and R6A is 20% cheaper than the R5B. It's already the next generation EPYC processors. It is x86 architecture. It's just not Intel. And your RDS SQL Server should run just fine on that. So why wouldn't you use R6A against the R5B?
And that would be a really interesting bit if they said, okay, the people who are going to be using the R5Bs, what would in the big picture, what's stopping you from switching to an R6 instance? So
yeah, there's nothing.
So what do we put in terms of our rating? I say I'm thinking about a 3.5. I mean, it's very clear.
Yeah.
There's nothing wrong. It's got plenty of examples. It's got all the data you need.
Sure.
It would be nice if there was a bit more bigger picture, but I mean that's not really.
Yeah.
Yeah.
Yeah, I give 3.5 for a. Do 3.5? No, we do.
There's a little half cloud there. All right.
So you give it 3.5 clouds. Okay. Awesome.
All right. Let's take a quick break, and then when we get back, we're going to be talking. What is our next one? We're going to be talking about the interactive video